In an attempt to figure out the slope of the tangent, which therefore is the slope of the curve, I'm going to introduce a new type of line. It's called a secant line. Again, I'll illustrate the picture. The picture should look pretty much the same as what I had a second ago. It'll look consistent here with the way the graph looks. And we had a somewhere around here, maybe something like that. Yeah, I'm going to fill that in. And we said 1 second ago that this was a comma f of a. Let me just make that a little bit clearer. Hopefully. There. All right, a comma f of a. Now, if I move further down the curve, let's just say b here, maybe. B. I map this up to the curve. I'll of course get a new point, and just like before, notationally, this will be b comma f of b. So now if I draw the line that connects these two, that is called a secant line. Use a different color. Secant line is a line connecting 2 points on a curve. That's what's happening here. We are connecting AF of A with BF of B. And the slope of this secant line is important. It is easily calculable. It must be the difference of the two y values, right? So f of b, right? F of b minus f of a. That's what this distance is here. Right? Also known as delta y. Right? F of b minus f of a. That's the change in the y values. The change in the x values, of course, is right here. Okay? And that's simply b minus a. So that's our delta x. There's delta x on the bottom. Okay? Just to write off to the side here, delta y over delta x, the change in the two coordinates for this particular secant line. This is, of course, not the same as the tangent we drew earlier, right? If we redraw the tangent on here, you'll see their slopes are certainly different, right? I'll draw this here. They are different lines with different slopes. In the picture I've drawn, the slope of the secant line is a larger positive value than the slope of my tangent line. Okay? But the slope of the secant line is going to help us immensely in calculating the slope of the tangent line, as I'll show momentarily. This slope of secant line also has a special name, and it's called the average rate of change of the function average rate of change average rate of change of some function f of x, as we have in the picture here, but specifically from a to b. Or you could say it differently, over the interval ab. That would mean the same thing. So keep that in mind. You may have learned about the average rate of change of a function before. And that's really all this secant line slope is. Okay? It's something you've seen before, most likely, average rate of change. We're going to use that to help us calculate the rate of change of the tangent line, i.e. its slope.